All right, welcome everyone. For those who are able to come and watch the live stream, welcome. And for those of you who are catching the recording afterwards, I hope you enjoy the show. Okay, today we're going to be looking a little bit about, a little bit deeper into variables. Let me adjust my own volume. We're going to look a little bit more into the variables, different types of variables, and how to actually find out what your what data type your variable is. And then we'll be jumping into some of the arithmetic stuff, such as basic operators, some of the advanced operators, the order of operations, and then we're going to jump into the Python math library as well. But before we do that, I wanted to look at the knowledge is power string formatting. Saw some fantastic examples this week on formatting the knowledge is power, but then I also saw some that were super advanced as far, or more on the intermediate level, as far as including functions and loops and stuff like that, but not efficient as far as coding goes. When you write code, you're never actually writing code for yourself. You're actually always writing code for the next individual, because you never know when you start working for a company, you never know what code you're going to receive from somebody else. And then when you start writing code, eventually you're going to leave. And eventually somebody else is going to have to take over the code and start working on it after you. So without further ado, let's go ahead and take a look at the knowledge, okay? So this is an example I saw from one of the students. It was pretty nice because they have a function right here that they called bar, and they're bringing in the value of words as one of the parameters for this function. Okay, so they go ahead and define phrase knowledge is power. We're only going to look at the final box one because the other ones are pretty simple. This one here, I found this one interesting because it uses a function, and the way they have it set up, there are more efficient ways to do it. Okay, so we set up the phrase knowledge is power. Every one of you guys had no problem setting that up. And they even put the entire phrase inside a single variable called phrase. Now in here in the function, so this is how you define a function for those that don't know. I think module 6 is when we actually start looking at functions. Basically you're saying define, you give your function a name, and a function is just something you can just call it over and over and over. And you just give it a value, which in this case we're calling words. Now this is where it gets a little bit weird. We're doing a print of an equal, and then we're ending with no space. So basically we don't want to go to a new line. And then we actually have a loop here where we're saying for I stands for an iterator in this case, in words. So whatever word comes in here, we're going to loop. If it's 10 letters, then we're going to loop 10 times. I will equal 10. We're going to print an equal sign each time it loops, but not print a new line. And then we're going to add 2 more on the end. So basically what they want to do is they want to do equal, and then 1 equal for every letter in the word, and then equal. Okay, not super clear when you first look at that. A new programmer might have to pause and look at that and say, why did they do it this way? Okay, and then we're going to look at bar. So they're going to print the top bar for the knowledge is power, and they're going to pass in the phrase. So the phrase is this knowledge is power, and they're going to pass it into the function. It's going to look at how many letters are in there, and it's going to run our function. Then we're going to go ahead and make a new line, and we're going to print a vertical pipe, which is that vertical line, which is above the enter key. It's usually the shift / and then they're adding the phrase, and then a space, and then the pipe again. So basically it's the same as the 2 equals, the length of the phrase, and the 2 equals. That way everything's lined up. And then we're going to go ahead and print the bar again. And yes, this is semi-dynamic because you can put in different length words, and it'll go ahead and adjust how many equal signs there are based upon the number of words. And when we hit play or run, we get our knowledge is power in the bars. And regardless of what phrase you pass in, it'll adjust itself every time. So let's look at 3 different levels, like a beginner, an intermediate, and an advanced programmer's way of doing this. Okay, so let's come down. This is the beginner and the most simple way to do it. Sometimes simple is better. So we'll go ahead and take a look here. This is my example of a beginner level, but it's simple and efficient. So we pass in a phrase, knowledge is power. We get the width. So basically we're doing length of the phrase plus 4 spaces because I want the +2 on the left and the +2 on the right, right? And then we go ahead and create our box. So we take the width, so we're using our print, width times equals. Print the vertical bar, space, phrase. In this case, we're doing an inline phrasing. And then we do another vertical pipe. Let's see, just want to make sure everybody sees this. Yes, okay, we are looking at the right thing. Okay, and then we go ahead and take another print statement with the width times the equal sign. And if we hit print, we get the exact same answer. Now, sometimes simplicity is best. We will look at the third advanced option. Actually does use a function, and the function is not a bad way to go for this. But sometimes when you're passing code on to the next person, sometimes keeping it simple is best. This is 5 lines of code, so we've got 3 here and 2 here, versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines of code versus 5 lines of code, and they're both dynamic. They both do the same thing. So sometimes simpler is better. But I mean, I'm not saying that this example is bad here, because it is great. They use the function. It's great they use the loop. That shows decent understanding of language, of languages in general, and Python. But we can do better, and we can keep it simple. So let's look at an intermediate version. Okay, so if we look at the example that the student made, and we look at the basic example, if I want to change from an equal to something else, let's say even these bars to something else, in mine, in the beginner one, I'd have to change it 1, 2, 3, 4 locations to change the symbol, the character. If we change it in this one here, we'd have to do 1, 2, 3, 4, 5, 6, 7 places. If we do it in the student example, to change the symbol. So taking it to the next level up would be able to change it, the symbol, quickly and dynamically. So what we can do here is, in the intermediate example, we take the phrase, and it can be any length. In this case, I say try to keep the code dynamic. We get the width, just like before, length of the phrase, plus 4. That way we get the plus 2 on the left and plus 2 on the right. And then here we actually take a variable, and we can set our symbol here. And you saw when I highlighted symbol, everywhere there was a symbol before, it now highlights the symbol down here. So we can say the width times whatever symbol we chose. Here we're doing a formatted string, so we're inserting the symbol. We have 1 space. We do the phrase, we have 1 space, then we have the symbol again. And then for the final bar, we do width times the symbol. And when you hit play, it'll do the asterisk, and it's still dynamic, but we can dynamically change what we make that symbol. So let's say we wanted to go to an exclamation. Okay, I just changed it at 1 spot. I hit play. Every single spot there is now an exclamation. Let's go back to an asterisk. I kind of like that asterisk. It looks kind of nice. We'll hit play. So just changing it 1 spot. And it changes all of the boxing symbology around it. And that was different here, where the student example there was 7. And in the beginner example, there was 4 different spots that you had to change it. Okay. Now, let's go to the advanced one. This one, we are defining a function. We don't want to call our function bar. Bar is not descriptive in what the function is. In this case, we're going to call it phrase in box. And that's what the function does. It puts a phrase inside a box. And it's going to take 3 inputs into this function here. 3 parameters is the proper term. Okay, so we have a phrase that we're going to bring in, and it is going to be of type string. This is called typecasting. We have a symbol, so we can dynamically set our symbol, and that's going to be a string as well. And then we're actually going to bring in a color, because I'm going to show that you can actually change the color of your inputs. If you saw on Discord, I actually put up an example of saying my name is Sir Lancelot, and the word Sir Lancelot was actually in blue. And the color will also be a string. And then we're actually going to have an output of none. Now, the colon string, and the output of none, these are not required, but they are good coding practices. So that way, when the next programmer comes in, they know exactly what type of information this function is taking. It's taking in a phrase that is of type string, so it's expecting a string. If it was of type float, you'd be doing different things with float, and if a string was being brought in, you know that would cause an error. So it's good to tell it what type of information to expect and what type of none. It'll still process if you bring in information, but it'll bring up flags if you bring in something else, okay? So in this function, it's very similar to the ones we just looked at, okay? So phrase in a box. We go ahead and get the width of the phrase plus the 4 spaces. And then we go ahead and create the box. We're using formatted strings, so we got the F here. We're using the width times the symbol. The symbol, we change the color, put our phrase in, and then we go back to our default color, another symbol, width times the symbol, and then I go ahead and print a blank line. And if we run this, nothing will happen because we're not actually outputting anything. We're not calling the function. But if you look down here, we have 3 different lines of phrase in the box that'll print 3 different things. And basically, we can just call this function over and over and over, passing in different pieces of information. So let's run the first one. Phrase in a box. This is knowledge is power. I passed in the phrase knowledge and power. I want to use the pound sign or the number sign, and I'm passing in color green 1. I'll show you the colors in a minute. And so what it does is it prints the green letters knowledge is power inside the box of pound signs. If I want to do this one, okay, it's going to print dynamic functions are important, because you can see it's adjusting the width, and all we got to do is just call this one-liner from now on, and it's going to automatically format our text for us with a new phrase, a new symbol, and whatever color we choose. And we'll look at the last one here. Phrase in a box, we're passing in hello. We're passing in a ASCII medium faded block, and we're going to go ahead and color the text blue. And you can see down here at the bottom, hello, and you got the box in blue. This type of symbol is common when you're playing like ASCII type games, to use this type of symbol here. Okay, let's go take a quick look at color. So this is the advanced one, where you define the function once, and the function does everything you expect it to do. It takes a phrase, and it puts it in a box, and then we just added the color to just take it to that next level of quality, and to demonstrate how to do it as well. And then each time you want to call it, you just do a one-liner to call your function. That's it. Pretty simple. If we come up here to colors, colors is just a text. So like if we wanted a shade of green, it's /033 open square bracket 92M. And each of these have their own color code here. So here's just an example of different ones that you can use. That's purple here. We could look at brown. If you want to use yellow, here's the color for yellow. There's also a symbol for degrees. Like if you wanted to use the symbol for degree, you could also put that in as a variable here. But using different colors, and then when we look at our definition function here, so come down here to the advanced, whatever color you pass in, it'll change to that color, and it'll go back to the default color right after we input our phrase. So when we call our function, pass in a phrase, pass in the symbol we want, and then pass in the color we want. As simple as that. All right, so that's just a quick review of the knowledge is power assignment that I saw. So not saying that the student did a bad job. They actually did a great job because they have a function, because they have the for loop. They're showing some advanced understanding of the Python language. But just as a person gets better at programming, they also get more efficient at programming. And sometimes simplicity is key. Readability is key. The code's not for you. It's for the next individual. Okay, without further ado, now let's go on to the next topic. Okay, talking about the variables. So when we look at the variables, these are names that we create in computer memory to hold a single value. You can't have 2 numbers stored inside a single variable. You can't have the number 5 and the number 6 stored inside a variable at the same time. Only one piece of information can be held inside a variable. It could be a string, because a string is one piece of information defined by those quotes. It could be a number. It could be a true or false. Okay, you can store that entire single sentence, a single number, or a Boolean, which is that true, false. If you put in a 0, 1, it may also read that as an integer. And then here's some examples, like my string. This entire example here, this is a string and is considered one variable, is a single variable, and it's captured by the quotes. Integer, my integer equals 5. My float equals 3.14. In this case, it's pi. My bool equals true. And for a Boolean, it has to have a capital T or a capital F. If it has a lowercase t or a lowercase f, it'll actually give you an error. And each of these fit inside a single variable. My string, my integer, my float, my bool, things like that. And you can see we're using the camel case with the lowercase my, and then each word after that would have the first letter capitalized for the camel case. That's what we use here at Leeward Community College. Okay, now let's look a little bit deeper how they're stored inside memory. Okay, I'm going to go through this text, and then I actually have a PowerPoint prepped. Let's see, I think that would be a window capture. PowerPoint. Let me pull this up real quick just so we can have a look at it. And we're going to make this the PowerPoint. All right. Yes. Okay, but for now we're just going to stick with the PowerPoint. Bring that in here. So we'll look a little bit more at that in a second here. Nope. Okay. So variables, they're stored inside your RAM when a program is running. Your hard disk drives, your solid disk drives, they're more for long-term storage, and they're going to hold on to it for long periods of time, but they're much slower. The RAM, when a program is started, your RAM is going to hold all the stuff that it needs right now to run this program. And it is your fastest memory that's not actually on the CPU itself. The CPU actually does have a limited amount of cache memory on it. I'll try and go a little bit deeper into the terminology because I was talking to some of the other instructors, and nobody really goes into hardware in the Intro to Computers course, and this is often the second class you guys take, so some of the terms may be a little bit strange. So yeah, RAM is random access memory, and if you ever look inside your desktop or even inside your laptop, it'll be a stick that's maybe about 1 inch tall. If it's a desktop, it's going to be about 8 inches wide. If it's a laptop, it'll be about 4 inches wide. And it often comes in increments of 8 gigabytes, 16 gigabytes, 32 gigabytes, even 64 gigabytes of RAM. The laptop I'm working on now has two 32 gigabyte sticks, so it has a total of 64 gigabytes of RAM. And the reason it goes on increments of 8 is because it's built on a binary system. Back in the day, you used to be able to get 128 megabytes and things like that, so smaller units. But it's much more common to see 2, 8, 4, 16, 32 gigabyte sticks of memory now, because Windows and a lot of the applications we use are memory hogs. And we're talking, so you're talking Windows. Windows is an active program, or OS X if you're using a laptop, or iOS if you're using a MacBook or a iPad or a cell phone, iPhone. Okay, the active programs that are running are eating up your RAM. The more programs you have active, the more RAM you're going to be using up. If you don't have a lot of RAM, you may even notice that your programs start running laggy or jittery as the RAM becomes filled, and it would actually start using your hard drive space as backup memory. Okay, this memory is extremely fast. Hard disk drives have these disk platters that have to spin, and it actually has needles that read the data, the zeros and ones, off that hard disk drive. Your solid state drive is a series of switches where there are no spinning platters or disks. They're much more durable than hard disk drives. Hard disk drives will crash over time. I mean, you're spinning these disks on bearings, and they will run out of time. Solid state drives, most systems have solid state drives now. It may be about the size of a credit card and about 3 or 4 millimeters deep on thickness. Or you may have one of those M.2 drives, which almost looks like a memory drive, where it's about 1 inch tall and it's about 4 inches long, and it kind of goes in endwise inside of your computer. The M.2 drives. That's also a form of solid state drive. In this laptop here that I'm using, I have a 2 gigabyte M.2 solid state drive. Solid state drives are very, very fast. Okay, going a little bit farther. So system memory, it consists of hexadecimal blocks that may look like this. So it'll be 0 at times, or 0x, and then the code after the x is the actual memory location inside that memory stick, or inside that memory module inside your computer. While it doesn't mean anything to us, and we don't ever actually directly go to these memory modules in like Python or C++, things like that, the computer uses this as a mailing address. It knows the address of every memory module, every memory slot on the computer. It knows the address of every single one. Using your operating system, Python has the memory manager, and they know the addresses of everything they put inside there. So it's like a mailing address for a house. You know your house mailing address, well, the computer knows your memory's mailing addresses. When you make a variable, for example, let's say you have my number, and you assign 5 using the assignment operator, equals an assignment operator. You take 5 and you assign it to my number. Python uses the memory manager to assign this value to an address. Okay, let's jump over to the PowerPoint. I think this will be a good example. Put that up right here. Let's go ahead and adjust the size real quick. so that way it fits and everybody can see it inside the window here. All right, there we go. Let's go ahead and hide PyCharm. Let's hide Google Colab. There we go. The memory module. And let me go ahead and make it a little bit bigger to reach. Just a single slider. Okay, so when we create a variable in the Google Colab, so today I'm using Google Colab, which is a web-based Python, that just to show another example of something you can use, and is extremely easy to use. Last week I used PyCharm. A lot of the students are using idle, which is a valid option as well, but you'll notice that PyCharm is more advanced and Google Colab is very advanced. Okay, so inside PyCharm, idle, Google Colab, you create a variable, myVar equals hello. So the type is string. It's going to take that memory and it's going to pass it into the Python memory manager. The Python memory manager will then find an empty memory slot. So slot 0x0001 has a variable or has a value 23 in it. Slot 0002 has a string already in it. It's John's birthday. So it's going to find the first memory slot available, which looks like 0003. And it's going to assign the variable in here. So we'll go ahead and put, or the Python memory manager is going to place the value hello, the string hello, inside 0003. The PyCharm, idle, Google Colab, whatever compiler or IDE is what they're called, whatever IDE you're using to do your Python code, the variables, it does not know myVar equals hello. It knows myVar, and it asks the Python memory manager, what is myVar equal? The memory manager will say, oh, I know where that's stored at. It's going to go to 0003 every time, and it's going to return inside myVar is the value hello. So if we want to print myVar, it's going to send a request, hey, Python memory module, what is the value of myVar? It's going to say, oh, I know where that's located. It's located at hex value 0003. There's hello. It's going to get it. It's going to return it. So let's bring this arrow over here. It's going to return it to the Python memory module. The Python memory module will then go ahead and pass it back to the compiler or the IDE. And the IDE is then going to print out on the screen a value that says hello. And it's as simple as that when we print myVar. The IDE, myVar isn't actually hello. myVar by the memory manager is a pointer or a reference to a memory location. So super nerdy. Do you need to have this memorized? No. Is it good to know? Yes. So that's why we're covering it now. Okay, back to Google Colab. Okay, so we looked a little bit deeper into that. So we basically covered that. The memory module, I use 0001, 0002 inside the PowerPoint just to keep it simple, but the memory module will look more like this on where it's actually stored at. Okay? So when we are creating those variables, what are the different types? Okay, so we have strings. A string is a list of characters enclosed by a double quote or a single quote. Some examples include hello or hello. You could even put the number 5 inside quotes, and it would be a string containing the number 5. Integers. These are whole numbers, no decimal values, so they're whole numbers. We call them integers, and an example would be 5. Floats have decimal values, and we're going to go quite a bit more into the power of integers versus the power of floats and accuracy. So you use integers whenever something has a discrete number. So if you're asking somebody their age, adults don't go, I am 26.3 years old. We don't talk that way. We say, I'm 23 years old. I'm 24 years old. I am 72 years old. That's not really my age, but just an example. So when we talk integers, we're talking whole values. Normally for somebody's age, you wouldn't use a decimal value. So therefore an integer, an age is a proper type value for an integer. But let's say we're talking money. Everything in the store doesn't cost $1, $2. No, it costs $1.62, $1.73. So 1.73. Those are types of value. They're continuous because it goes 1, 1.10 or 1.01, 1.02, 1.03, and it just continues. It's considered a continuous value, a continuous data type. So therefore, it would be float. Integers, they do incremental or discrete steps. It goes 1, jumps all the way up to 2, skipping all the decimal values in between, skipping all the way up to 3. So 1 is discrete and the other one is continuous. Floats are continuous values. Pi is a good example, 3.14 of a continuous value, because you're talking a circle. A circle doesn't have lines coming out of the center of the circle. No, it is a continuous line going around the edge of the circle as the values of pi are continuously processed. Okay, and then Boolean. Boolean is a true or false, or a 1 or a 0. Pretty easy to get that one there. Okay, so as mentioned before, we use camel case here at Leeward, where the first word is always lowercase, and then the second, third, fourth word, if you have multiple words, would have capital letters. So one of just the 2 words would be my number, and you have 3.14. Another example would be first computer player. So let's say you're playing Warcraft 1, 2, 3, or StarCraft 1, 2. It doesn't matter. You might be playing against multiple computer characters. In that case there, you might first computer player will be the orcs. Second computer player may be, if you're playing StarCraft, might be the Zerg. And so you can have a good variable name that describes what the type of data inside it is. And then you could have a Boolean such as play game. And that could be true or false. So while it equals true, you just want the game to keep playing. But the moment the player says menu, quit, it'll change play game to false. And the next time it loops through the game cycle, it's going to say, oh, the player hit quit, I'm now going to quit, and it'll exit the program. When creating variables, it's important to have descriptive variables that will help programs understand the code better. A good example is student ID number equals 23. Student ID number, if anybody sees that variable student ID number, if the next programmer sees student ID number, they automatically know exactly what type of data is inside that variable. A bad example would be SN equals 23. You might understand SN equals student 3, but I guarantee the next programmer will not understand that intuitively just by looking at SN equals 23. All right, variable rules. So there are some rules that go with variables. All right, variables must begin with a letter or an underscore. All right, let's see. For example of an underscore, change the format here, underscore my var. Okay, so an example of that would be underscore my var. Now, it is a good practice to not use the underscore for your standard variables that you're going through. There are special cases when you use that underscore, and we'll cover that in the upcoming weeks here. Okay, variable names can only contain letters, numbers, and underscores. Don't put exclamations in them. It's not a password, so we don't put exclamations. We don't put @ signs in the variable names or $signs in the variable names. So letters, numbers, and underscores only. And finally, variable names are case sensitive. So the variable my number with a capital N is not equal, so the asterisk equal sign means not. So asterisk means not, and the equal for equal, so not equal to my number, because you can see this has a capital M where the other one has a lowercase m. That is 2 different variables. Okay, so I got an example here. So my greeting equals hello. Okay, and we expect it to print my greeting, because in this case where our expression is a variable, we can also put a string in here directly, and then we're going to print a blank line. And then let's look at some GPAs. Let's say we have an A, B, C, D, and an F defined for GPA variables. In the print statement itself, we can actually say A plus B equals, and then in the curly braces, we can actually put a some expression. So we're saying A plus B in parentheses, because we want to do that first, divided by the value 2, because we're doing 2 letters. And if we hit play, connecting real quick, it's been a while since I've ran this code. It's the first time I've run this code, so connecting, it'll run here in a second. All right, there we go. So if we see it printed hello world, and then it printed, the F means it's the formatted string, so we printed A plus B equals, and it's going to take whatever's inside the curly braces, and it's going to evaluate. Evaluate means figure out the value of 4 plus 3 divided by 2, which gives us 3.5. Okay, let's look at some data types. So we looked at integers, and they're the whole numbers. I don't want to beat this one too much, but you wouldn't say somebody has 3.1 cats. You say they have 3 cats. If you put in a Boolean of 1 or 0 into a variable, it may recognize that as an integer instead of a Boolean. There is a way to typecast that when you're creating the variable. We can take a look at that at the end. Floats, floats are for continuous values. Weight goes 1 or 0.1 pounds, 0.2, 0.3, up to John might be 172.4 pounds or 0.4 pounds. Jason might weigh 193.7 pounds. Jill weighs, well, we can't say how much Jill weighs. That'd be rude. Another example would be 127.5 degrees in a circle is a bigger angle than 34.6 degrees. It's continuous. You can compare them together, and that circle is continuous going around. Another common float example is pi. We talked about that one earlier. Okay? How do we check what type of data is inside our variables? So whenever you have a variable, it's easy to check that data. Just like we have the print, and then you can put an expression inside the print function, there's also a type, and then you can put a variable inside that type, and it'll tell you. So let's look at this next code block. So let's say we have my number, and it equals 5. We're going to hit go here, and we'll see what it says. Okay. The first line is print. We're doing type my number. And you can see we actually did this type my number inside the print block. You can nest functions inside of functions. So we get the type first, then we go ahead and print that out. So it is of type class integer. So we know that my number data type is an integer. We can add more detail to our print functions. We can say, okay, we're going to do some formatted strings. So up here, we're going to do format the string, my number equals sign inside the curly braces, and is type curly braces type my number. Now you see I have that equal sign at the end of the variable called my number. What that does is it actually will print my number equals, and it will also print the value of it. If you take out the equal sign, let's look real quick here. So if you look down below, my number equals 5. If we take off the equal sign and we run it again, it's just only going to give us the value of the data. But if we put that equal sign on there, it'll print out my number equals and the data type. So that's a nice shortcut if you don't want to have a bunch of extra code. It's one of those cool little tricks that you could use. Okay, and we can see that's type integer. Well, in the next one, we're going to do my number equals 5 divided by 5. Those are both integers, but when we resolve it, it actually says it's a float, and the value is 1.0. Anytime you divide in Python, the resulting data type will always be a float. If you want to change it into a string, you're going to have to typecast that, which we'll look at in actually like 2 or 3 statements below. Okay, the last one is my number equals 5, but if you notice 5 is in quotes, which means it's actually going to be a string. And if we look at the data type, my number equals 5, it shows it inside single quotes and is a type class string. So you can check the variable, just do type the variable, and you'll see it'll be an integer, a float, a string, or a bool. Okay, some more ways you can look at the math. The key point is that you can always check the data type and what it contains. You can also typecast or convert it from one type into another. For example, if you have an expression 5 divided by 5 and you wrap it in int parenthesis, it's going to force it to be an integer or return an error. If it's a string, you can't make a string into an integer. That would return a value error. Okay, you can typecast into an expression. You can change a value into a float. You can change anything into a string, and you can check or change something into a Boolean. You could check a single value. So let's say we print, and we're going to change 5.5 into an integer. You're going to get the result of 5. You can also do expressions of 5 divided by 5. If you wrap that in the typecast for integer, you'll get a 1 instead of a 1.0. So let's look at this next block here. We have my numbers 3.14. Let's go ahead and run this. Okay, so 3.14 is of type float, okay, for the first print statement. Now let's convert it into an integer into a type check. So if we look up in the code block, we have my number. we're going to typecast my number as an integer and put it back inside my number. Okay, so then we're going to check it, and we can see my number is now 3. It chops off the .14. It does not round it. It just chops off the decimals. So basically, it always rounds down. Just chops those decimals right off. You could have 3.99. If you typecast as an integer, it's going to change it to 3. It does not care. .99 is very, very close to 4. It will always round down. That's also a type of floor division. Floor, because we're going to the bottom of the integer. Ceiling would be going to the top of the integer, and we'll look a little bit at ceiling and floor later on. But if you do an int typecast to a float, you will always get just the whole number, and it chops off the decimal value. Okay, let's look at the next one. Now we're going to convert this into a string, and we're going to check it again. So we're going to typecast my number as a string, and then we're going to assign it back inside my number. So if we look at my number now equals 3, and it has the quotes on it because it's now a string, and the class is of type string. All right, so that's a lot of stuff going to variables. We looked at the different types of variables, what type of information you put into them, how to change from one variable type into another variable type. If you try to do a float or an int to a word, you'll get a value error because you can't change words into numbers. If you have a string that is a 1.2, you can change that into a float. But if you try to change that into an integer, a dot inside a string is a period. It's not a decimal, it's a period. So a float value will understand that and convert it into a decimal. An integer doesn't know what to do with a period. So if you want to do something like that, you can actually double typecast. You can actually go from a string to a float, then to an integer if there's a dot inside it. All right, going on to the next part, basic operators. So this is looking a little bit this week and looking a little bit at next week as well. The basic operators, just like on any elementary school calculator, is plus, minus, multiply, and divide. The plus sign, which is the shift equal sign, is your addition. The minus sign is between the equal sign and the 0, and that's your shift underscore, actually, is what it is, and that gives you the minus sign. Multiplication is the asterisk, or shift 8, and your division sign is just to the left of your right shift key. Shares the button with your question mark key, so shift question mark would give you the division symbol. Using these basic operators, we can do everything from making a game, training AI, teaching AI to do machine learning, predict future events using predictive and data analytics. Also make basic, graphical games as well. It all starts with these basic operators. So how it would look is 5 plus 5 equals 10. And if you notice, there's a space between the 5 and the plus symbol, and between the plus symbol and the 5. That is common Python industry practice. That's like a standard. You use spaces, you spread out to make it more readable. 5 minus 5 will equal 0. 5 times 5 is 25, and 5 divided by 5 is a float value of 1.0. So let's go ahead and run some code, and we'll see what it looks like. Those numbers above, with the 5s, that's super easy. We can do that as a human in our minds, no problem. But let's say you have a bunch of very large numbers. If I try to add all these together, I'll either need a calculator, or I'm going to need to write it down, or I'm going to have to take some time to mentally rearrange these and add them all together. Same with the 5 times 9 times 4 times 2, and you can see in the curly brackets I have the equal sign at the end, and it's going to show us the equation, or show us the numbers and what they equal at the end. So let's go ahead and hit play. And this is a good example of why you would use that equal sign when you're evaluating an expression. So look, it shows us the expression and the equal sign, and then it actually tells us what the value is, the evaluation of that expression. So we got 2,188 if you add all these numbers together here, and 360 when you multiply all these numbers together. And it does it almost instantaneously for us using these basic operators. And if you see down here in the example, we're using a formatted string, but we have the spaces between the operator and the numbers that we want to multiply. Okay, let's look at something more realistic. This one's going to be a little bit more advanced, but I just want to show a way that you can use adding, subtracting, multiplying, dividing to actually do something. So let's say you have an Uber driver who works at Leeward Community College. He takes 2 classes per semester, and he needs to balance his budget. So if we come down here, we can look at this little bit of code here. A budget for the Uber driver. This is going to be his monthly income. In the beginning, we're going to use a dictionary, so you may see this structure right here. Don't stress about it too much. Basically, we're just grouping together these. So January equals 3,250. February equals 3,300, and we're just grouping all these together inside a single variable called monthly income. There are two types of structures that we're going to look at, I believe, in week 4, called lists and dictionaries, or module 6, lists and dictionaries. I just have it here, just so you know, January equals 3,250. So don't stress about that. I tried to make it an easy to read format, and by the end of this course, you'll understand exactly what this is. I just want to demonstrate that you can add these kinds of things together to actually build a budget. So we have a dictionary called monthly income. It has these pieces of data for 12 months. It shows exactly how much money he made as an Uber driver for those 12 months. Okay, so we're going to calculate the average. If you remember what average is the sum of all of the values added together divided by the number of values. So let's say you have 12 months, you add together all 12 months, and then you divide by 12. So the average monthly income is the sum. This is a built-in Python function, sum of the values inside monthly income. It's just going to add them all together, divided by the length, len equals length, another built-in function, of the monthly income. So the length of the monthly income is going to look, it's going to go, okay, what is length? It's going to go 1, 2, 3, 4, all the way until it hits the last one. It's going to say, oh, there's 12 values inside here. So it's going to add all the values together, and it's going to divide by 12. And that's going to give you your average monthly income. So here you can see we're using the division basic operator. And then we're going to print the monthly average income with a 2 decimal spaces, or decimal places, float value. Let me go ahead and hit run on this just so we can see what the final result looks like. And as we're explaining it, you'll be able to actually understand a little bit better. Okay, so all that code that you just saw here, all this code here, just to get this budget here, but we're letting the program do all the math and calculations for us. So as I said, it's going to print average monthly income. It's going to tell us what the average is. So if you look at all 12 months and you let it average it out for you, sum divided by the length, number of entries, this Uber driver, who's also a Leeward community student, makes $3,748.33 driving for Uber every month. We'll look at expenses, but their total monthly expenses is going to be $3,481.50. And you see we got this by doing the .2f. So .2 means have 2 decimal places, and f means keep it as a float value, okay, or a fixed 2 decimal places. There's also a couple other different options, but F is the most common one, where you want a fixed 2 decimal places, no rounding involved. Okay, and then the monthly gross income is going to take that month's income minus the expenses for that month. So like say in January, he's actually negative $230.50 on his budget. February, he's negative $181.50 on his budget. But March, he's positive $680.50. So not every month will be a negative or positive. It will average out to about the 3,748 minus the 3,481. That's about a $300 difference, $250 difference. So calculate the total gross income minus the total expenses, and the annual gross income, so that's all 12 months combined, minus the expenses times 12 months. At the end of the year, he should have positive $3,202.00. Hold on one sec. I need to turn on lights because it's getting dark in here. All right, help with some light here. Getting hard to see my own keyboard. Okay, so let's go and look at how did we do this using basic operators. Okay, so as mentioned, we had the dictionary. We're just dividing to get our average income. Expenses, this is how you probably know how to do it now, where you just make a variable and then you put a value. So our rent expense equals $2,165. Our food expense is $750. Medical insurance, $85. Car insurance, $125 a month. Car gas, so in this case I'm using a nice variable name, so for the car, the gas costs $95 a month. For your cell phone, it's $65 a month. And then because he's a Leeward student, we take each credit, it's $131 per credit hour for in-state tuition, times 3 credits for a class, and the student's taking 2 classes in the fall and 2 classes in the spring, and then we divide that by 8 months because you have the 4 months in the spring and the 4 months in the summer, and that gives us the tuition expense per month if you only look at 8 months. And it's going to spread that out over the whole year because a budget should be also be annually balanced as well. That way you don't have big spikes depending upon education expenses and things like that. All right. So you can see we did the multiply, and we did the divide. And we did the parentheses around the first part just to group it together, divided by 8 for the number of months in a year that they're doing education. Okay, next we're going to calculate the combined monthly expenses. We're going to take the monthly expenses, and you guys know how to do this by now. We're just going to add them all together using the plus symbols. And you can see we're adding the variables because the variables have the information from here inside them. And we have the space plus space for the proper formatting. We're just using the spaces, adding them all together. And then total monthly expense is monthly expenses, and then we're going to go ahead and colon dot to F for 2 fixed decimal places. And we're going to figure out our annual expense. So we take our monthly expenses and we multiply it by 12 because we're assuming that the expenses do not change on the monthly basis. They're pretty static. We'll go ahead and get a blank line and then calculate the gross income by month. So the total income, we're going to print monthly gross income. Now this is a for loop. We learned for loops in module 4, which makes sense, for loops in module 4. So we're going to look at the month, which is January, February, March. We're going to look at the income, which is the amount of money inside that dictionary that we talked about earlier. And we're just going to look at each one. So it's going to look at the first entry, and it's going to take the amount of money minus the monthly expenses, and it's going to print that out. So first it'll say the month that it belongs to, the amount of income minus monthly expenses, and it's only going to give that monthly gross income because that's inside the curly braces there. And then it's going to go ahead and add that monthly, that total income into, or that income, not with the monthly expense taken out, but it's going to take the income and add it to total income. This is a shorthand. We'll talk about this in a little bit also, but basically we're taking total income, which equals 0. We're going to add the income to it and put it back inside total income. So we're doing, so this is the same as saying total income equals total income plus income. So this is a shorthand. So basically I'm taking total income plus income and I'm putting it back inside the total income. That's all that means right there. It's just taking out that duplicate need for total income there. And we'll look at that. You can do that with the other operators as well. It's going to do that 12 times because there's 12 months and 12 different incomes. And it's going to print out each one. So as you see down here, monthly gross income is going to do January, the gross income, February, the gross income. The total income does not have the expenses taken out of it. It's just the maximum amount of income. Okay, and to get the annual gross income, we're going to take that total income minus the total number of expenses for the annual year. And then we're just going to print them out. So with using the minus sign here, print them out, and then we're going to go ahead and take that annual gross income, the final value of how much money they should have at the end of the year, and we're going to go ahead and do a fixed 2 decimal places at the end of that for the printout of that function, our variable. Whew, all right, that was a lot. Okay, this notebook here, I will email to all the students. You guys will be able to come through here. Google Colab is free, and you'll be able to come to this notebook here. You'll be able to read over all this information. You can even make changes. If you make your own notebook, you can copy it and make changes and edits. In my version, you'll only be able to view it, but you'll be able to see how all this works. And these are actually fantastic examples as we move into future modules on how to actually make those dictionaries, how to build those loops and things like that. So use this information in your future modules as well. The whole point that we're looking at this week is the arithmetic that you're using here, the adding, subtracting, multiplying, dividing. All right. Shorthand notation, okay? So we can add things quickly with shorthand notation, such as my number equals 5, my number plus equals 7. That would be the shorthand notation. And then we're going to print my number, and that should give us 12 because we put 5 inside my number, and then we added 7 more to it and then put it back inside my number. Values are assigned to variables from right to left. So everything on the right of the equal sign is processed first, evaluated first, then it assigns it using the assignment operator, which is the equal sign, into the variable. Thus, that'd be the same as, so the number we had up top there was my number, which is 5, plus 7 is 12. It evaluates the 12, and then we're going to assign it into my number. Python understands that you want to add values from right to right of the assignment operator first, and then assign it back into whatever the variable is. And so you can do this for any of the basic operators. So you have plus equals, minus equals, multiply equals, divide equals, and then we can demonstrate that. So let's go ahead and run this code here. So we're making a number equals 5. Actually, let's look at what is the final answer. So if you're online and you're in the chat, you can go ahead and try and figure this one out on your own first and put it in the chat if you want. So we take 5 plus 5, and then we assign it. My number now equals 10. Minus 5, my number now equals 5 again. Times 5, that would my number now equals 25. Divide by 5, my number should equal 5. And let's check. Next line, print my number. It equals 5.0. And the reason it equals 5.05 is because the last operator we did there was divide, and divide always returns a result of a decimal value or float value. Okay, let's look at some advanced operators. We have floor division, which is divide. We have modulo, which is the remainder of a division. If it doesn't, instead of getting a decimal value, we can actually get the remainder out of it and ignore what the actual operand is. Yeah, I think that's the right word, operand. Or we can do exponents, which is like to the power of 2, to the power of 3, or, 2 to the power of 3, something like that for the exponents. Floor division will divide two numbers, and it'll return an integer value. So we're dividing, but it gives an integer rounded down to the nearest integer. Modulo gives you the remainder of the division operator, and the exponent operator is just like an exponent in mathematics, power 2. So here's some examples, and then if we actually run some code, let's go ahead and run the code. 5 floor division by 4, so divide by 4 gives you a 1, not a 1.25, which would be the just division. 10 modulo 3 is saying 3 goes into 10, 3 goes into 10 3 times. That would give us a 9. 10 minus 9 gives us a remainder of 1. So we have a remainder of 1. And then 5 to the power of 3 is 5 times 5 times 5. As shown up here, 5 to the power of 3, 5 times 5 times 5. So that'd be 5 times 5 is 25. 25 times 5 is 125. Order of operations. So in elementary school, we all learned PEMDAS. I learned the phrase was, "Please excuse my dear Aunt Sally." That basically applies still now. So PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. And you take care of the math evaluation in that order. In Python, we have those couple other things like the floor division, the modulo, and the exponents. So we also need to look at those too. So we still have parentheses first. So please excuse for the exponents, multiply and divide, get taken care of next. Then after regular division, then you look at floor division and then modulo. So if you had a modulo and a floor division and a problem, it would do the floor division first, then it would do the modulo. Then we look at our addition and our subtraction. So it is almost PEMDAS, and you're just throwing floor division and modulo right after division, right there in the middle. So let's look at examples. Okay, we'll go ahead and run it. So you'll see the answers are 24, 24, 32, and 19. So we're taking 8 plus 8 times 12 equals, in here it's going to evaluate for us. So basically it's taking 8 times 2 plus 8. If we have done 8 plus 8, that gives 16 times 2. That would have been 32. So that's the wrong answer. So multiplication first, then we do addition. If we put parentheses on it, now that changes things, okay? If we put around the 8 times 2, well, that was already going to occur first anyways, and then add 8, that's why we have the 24. But if you put the parentheses around the 8, 8 plus 8 is 16, times 2 is 32. Different answer. Parentheses have a big effect. And then if we look at this last one here, we have a division, an addition, a multiplication, some parentheses, a minus, and a modulo. Okay, so first thing is parentheses. 3 plus 1 is 4. Then we look at multiplication. Times 5 is 20. We have a division here. So 8 divided by 4 is 2. So we have 20 and 2. Then we have modulo. Minus 7 modulo 4. So 4 goes into 7 one time with a remainder of 3. So we have 2, 20, and negative 3. So now we can add. So 2 plus 20 is 22, minus 3 is 19. And this is a float value because we do have one division right here. So we get a 19. So let's practice some of these. So our first problem, for those that are watching, try and do this in your mind first, and then we'll walk through it, okay? So the first problem is 5 plus 3 times 2 to the power of 2 minus 6 divided by 2 in parentheses. Okay, so here you can see it in the standard math notation, where 2 to the power of 2. So first you do your parentheses. So 6 divided by 2 is 3. 2 to the power of 2 is 4. 3 times 4 is 12. Plus 5, 17. Minus 3, so 6, 15, 14, should be 14. Let's hit play and see if Math in Public works. Whew, okay, 14.0. If we look at the next one, we do our parentheses first. It doesn't matter which one we do first. Okay, so we have 10. We have 3 to the power of 2, so that would be 3 times 3 is 9. 4 minus 9 is negative 5. Negative 5 times 10 is negative 50. Plus 10 divided by 2. So 10 divided by 2 is 2. So negative 50 plus 2. So that should be negative 48. All right, negative 48. I'll leave this last one for you guys, but we'll walk through it. Okay, 2 to the power of 2. Or first the parentheses, so that gives us 10. 2 to the power of 2, that's 4. Multiply them together. 9 divided by 3. And then do the addition. So 9 divided by 3 is 3. Negative 3 plus 4, that should be positive 1. And then evaluate this plus the 1. And that should give you a 41. Whew. All right. So earlier we talked about integers and float. All programming languages like integers, or because they are whole values. When you go to float, we lose precision. So all computer languages are perfect. That should be perfect, not prefect, with dealing with integers. However, all languages have the issue with floating values and keeping that precision. Okay, this is because binary digits, such as this 8-bit binary code for 51 is 00110011. That means 1 plus the 2. This is the 4. That's the 8. 16 plus 32. So 32 plus 16 plus 2 plus 1. And those are different binary positions, give you a total of 51. That is an integer value. Binary thinks in integers. It's always a whole number. In order to create decimals, what it does is actually takes the leftmost bit. So in a 64-bit float value, which is 64 bits, it takes 53 digits for the float, and it uses the remaining digits to approximate the float decimal value. So Python is only accurate up to about the 15th decimal position, which would be here. So if you took this decimal value, .194837264853839, we know we will be accurate up to there. Anything after that varies per system. So every system, based upon the CPU or processor that you have, the operating system you're running, the memory modules you have, and if you use the GPU to calculate it, the GPU that you have will give different values for anything after that 15th value here. So if you were to run this decimal value here, you might not get 053. You might get something totally different. The only way to get identical numbers is to have two identical computer systems, hardware and software. If you really want to get deep into the accuracy of floating point, all languages have this issue here. But on the Python docs, so the company that makes Python, this is their documentation. You can go in there and you can look up more about floating point values. But just know any floating points after the 15th decimal place becomes unreliable. because of the way binary and float values work. It's interpreted, it's an approximation. So every language has this issue. In C++, your standard integers or your numbers are only 32 bits. I guess this should be your floats are only 32 bits. You also have doubles, which would then be 64 bits. In Python, we just have a single decimal value that we call float, and it is automatically a 64-bit. So it's actually just as equal as a double float in C++. That's great for scientific utilizations in mathematics. And it is twice as accurate as C++. Python has a decimal library, so a special library just for decimals that you can use 28 bits. That's even more accurate. And then you also have NumPy, which has a library called Float 128. So it uses 128 bits. Actually, I need to double check. Yeah, because the decimal library is supposed to be more accurate than the standard float, but here it says 28 bits. So I need to double check on that one. But there is a decimal library that's supposed to be twice as good. So that should actually be 128 bits, not 28. And then NumPy, which is another special library used for numbers Python, is what it stands for. We'll use this a lot for like matrices and things like that for linear algebra type mathematics. Has a float 128, which is then 4 times better than C++ or C#, some of those other languages, and twice as good as the standard Python float. Enough geek speak, let's look at an example. So if you took in your mind what is 0.1 plus 0.1 plus 0.1 minus 0.3. When I do this in my mind, I get 0. My mind understands 0.3 when you add them together is the same as 0.3 when you subtract it. That should equal 0. But Python, since all decimal values, all floats are an approximation, let's go ahead and do that. So we'll do that same math here, and we'll see what it gives us in a print string. It equals 5.55 all the way up to 15 decimal place times 10 to the negative 17. So what we would call that in mathematics, we would say that is near 0, because take this decimal place and go left 17 more times, we'd have 16 zeros followed by this string of numbers right there. That is very, very, very close to 0. But if you notice, it is not 0. So if I were to say is 0.1.1.1 minus 0.3 or decimal 3 equal to 0, Python would tell me false, because it is not equal to 0. It is equal to near 0. Putting what we learn in practice. Okay, so if you want to do this practice problem here, let's look at a college student at Leeward University wants to buy a drink from the vending machine outside the General Sciences building at Leeward Community College. The student inserts a $20 bill into the machine. They select a Red Bull, which costs $3.12. So for the first part of this problem, try how much money should the student get back. We want to use basic arithmetic for this. And the second part, the machine needs to know how many of each kind of bill. So how many 10, 5, and $1 bills, and how many quarters, dimes, nickels, and pennies need to get returned to the customer. Because the machine doesn't understand, whatever, $12.62 is. There is no thing that it can just give you that. It has to break it down into individual pieces of bills and individual coins, and then pay out that bills and coins. To figure out the second part there, you'll need to use division and modulo. Okay, so that's our problem that we want to practice. Let's see. Let's see. I don't see anybody online now, so we'll hold off on doing this one here. If anybody wants to figure out how to do this one here, really valuable to know how to do this. We'll take a look at this one next week here. Okay? Try and figure it out. If you can't figure it out, we'll look at this one next week. Let's look a little bit at some more advanced arithmetic features. So built into Python itself, there's the div mod, which stands for division modulus combined into one, and you pass in 2 values. Okay, so the x and the y. It's because you want to figure out your value you want to divide, what you want to divide it by. Okay, and the div mod function takes in 2 values. The quotient and the remainder are the outputs that come out of this in a single function. So you're doing the division function and the modulus function at the same time, or operators at the same time. And you're assigning the quotient, which will be the whole value, and the remainder, which will be the remainder after that. Since this returns 2 values, you can also assign them in a single line. So you could have a variable called my quotient and a variable called my remainder equals div mod 17.5. So if we go ahead and run that down below, div mod, we know that 5 goes into 17 3 times. So the quotient is 3, and then 3 times that would give us a remainder of 2. So the remainder is 2. The modulus value is 2. So using a single line, you can do the division and the remainder at one time. And it outputs 2 variables or 2 outputs, the quotient first, then the remainder value. Absolute value. So absolute value is awesome if you want to return something based upon how far it is from 0, the absolute value of 0. Useful for figuring out how far, such as the angle left or right of 0. You don't care if it's minus or positive, you just care that it's tilting and by how much. So the absolute value of -5 should be +5. And these are built in. Now, if we look at the math library, we're going to go over this one real quick because we're just over an hour now. And I know nobody wants to watch a 1-hour live stream video. So for those of you guys watching, we are going the full hour on this one, unlike last week. But it's all great, fantastic information. So I hope you guys appreciate it. Okay, so the math library. The power of Python is in its libraries. There are so many different libraries. That's how it does AI and machine learning and data analytics and stuff like that. Well, one of those available libraries is called the math library. So to get to the math library, what you would actually do in Python, you'd say import math. That's it. You'd say import math at the top of your Python program, and that imports in the entire math library and all the power that comes in it for advanced mathematics. Other libraries also have some duplicate features as well. So math.square root gives you the square root of x. If you want to do math.pow, it gives you the power. So you give the base value, you give the exponent value, and you can also do an optional z value as well. I forget what the z value is off the top of my head. Let me look that one up real quick. Python pow, and let's see what returns. There we go, documentation. It should be modulo, I believe, but let's look that up. So I'm actually on the Google site. You can see it up here. I'm looking up, this is on the Python documents. So pow, we click on that, and yes, that is a modulus. So you can actually do modulus, like you could do the base times the exponent, and you can see how many times does 2 go into it or 1 go into it, something like that. But it's optional. You don't have to have that. You could just do x comma y and then close the parenthesis if you wanted to there. And that's the same as the basic Python power of just exponent of just asterisk, asterisk, or multiply, multiply. We talked earlier about the floor division, or if you change a float into an integer, then you go down, you automatically chop off the decimal and you go down, round down to the nearest integer. If you want to round up every time, then you do math.ceil, and it's called sealing, and you're rounding up a float value to the nearest integer. Just like you have // for the floor division, or you can just convert something into an integer, that takes you down the floor, but there's also a mathematical function for that called math.floor, and then you put your value in there, and it's going to round your float value down to the nearest integer. So sealing goes up, floor always goes down. Factorial is just like mathematics as you think of a factorial. That would be like, what is the factorial of 6? You know, that would be like your 1 times your 2 times your 3, you know. And then you have your greatest common denominator, greatest common divisor. They're all the same thing. Math.gcd, you put in your two values, and it's going to find that greatest common denominator for you. Very useful for mathematics. So that's all I have for this week here. Next week, we'll go a little bit more into mathematics and using them. And we'll actually, so putting in practice, try and figure out how much change the student's going to get back and what type of bills are going to get back, and see if you can put that into code. And then what we'll do is we'll go ahead and take a look at that next week to see an efficient way of doing that, and we can actually do a comparison on how easy or difficult was it for you to do it versus the one I put together. And every programmer does things slightly different. I try to keep them as simple and easy to understand as possible, but who knows? One of you guys might actually have a better solution than I have. All right, so I hope everybody appreciated this. If anybody has any questions, email me, contact on the Discord, and I'll do my best to answer those questions as soon as I can. All right, hope everybody had a great week, and don't forget your assignments are due this Friday. Program 1 for module 1 is due this Friday. Thanks. Everybody have a good day. Bye.